Welcome, everyone. Today, we are analyzing a pivotal moment in cybersecurity history, the launch of Project Glasswing. As artificial intelligence crosses a terrifying new capability threshold, we are going to explore how the tech industry is banding together to prevent a global security meltdown. Let's get started. Let's start with the what. Project Glasswing is an unprecedented, industry-wide defensive cybersecurity coalition. In early April 2026, Anthropic realized their newest frontier model, Claude Mythos Preview, had reached a terrifying milestone. It could autonomously discover and exploit zero-day vulnerabilities in almost any software. Knowing that releasing this publicly would be catastrophic, Anthropic restricted the model. Instead, they formed Project Glasswing, bringing together 12 of the world's most powerful technology companies, plus over 40 organizations that maintain critical infrastructure. The mission is simple but urgent. Use this incredibly powerful AI to scan, identify, and patch the foundational software of the internet before adversaries can build or steal similar capabilities. It is the ultimate race against time. Take a look at this structural flowchart. At the top, we have the Claude Mythos model, which acts as the engine. Notice that the access is strictly gated. It flows exclusively into the Project Glasswing Consortium. From there, the capability is distributed across three main pillars: cloud giants, elite security vendors, and critical financial and hardware institutions. All of their individual scanning and patching efforts converge at the bottom, resulting in a hardened global digital infrastructure. Why was such a massive coalition necessary? We have to understand the sheer scale of what Claude Mythos achieved. In cybersecurity, we talk about the patching window. The time defenders have to fix a bug before hackers exploit it. AI has collapsed this window from months down to minutes. During its testing, Mythos autonomously analyzed OpenVSD, widely considered the most secure operating system on Earth, and found a fatal vulnerability that had sat unnoticed for 27 years. It looked at the FFmpeg media library and found a 16-year-old bug that had survived 5 million automated tests. Human defenders simply cannot match the speed or depth. The traditional asymmetry of cybersecurity states that an attacker only needs to be right once, while a defender must be right 100% of the time. Glasswing was formed because we finally have a tool that can analyze the entire defense surface simultaneously, flipping that asymmetry. This timeline compares traditional methods with the Mythos era. The top path shows traditional fuzzing, blindly throwing data at software. It missed critical bugs for over a decade and a half. The middle path shows Mythos applying deep semantic reasoning to find that same bug in hours. If a bug like this were released publicly without warning, it would lead to immediate global exploitation, the red path. Instead, Glasswing intercepts it, funneling that discovery directly into preemptive patching. Let's cover the basics of how this coalition is funded and structured. Scanning the foundational code of the internet requires an immense amount of computational power, which is highly expensive. To make this feasible, Anthropic committed $100 million in model usage credits directly to the Glasswing participants. These partners aren't running this on consumer laptops. They are accessing the model securely through enterprise infrastructure like Amazon Bedrock, Google Vertex AI, and Microsoft Foundry. But Anthropic also recognized a critical gap: open-source software. Most enterprise systems are built on top of free, open-source libraries maintained by volunteers who cannot afford massive AI compute bills. To solve this, Anthropic donated $4 million in direct cash, $2.5 million to Alpha Omega and OpenSSF, and $1.5 million to the Apache Software Foundation. This ensures that the open-source community gets the same defensive AI superpowers as the tech giants. This pie chart visualizes the financial weight behind Project Glasswing. The overwhelming majority of the funding, $100 million, is dedicated to compute credits, allowing partners to run the heavily intensive Mythos model. The crucial remaining $4 million is carved out as direct cash injections for open-source security foundations, ensuring the foundation of the web isn't left defenseless. How exactly does Glasswing operate day-to-day? The methodology is a multi-step, AI-driven pipeline. First, it automates triage. Security teams are usually drowning in thousands of low-level alerts. Mythos instantly evaluates and deduplicates these, separating the noise from critical threats. Second, it executes deep scanning, diving into source code and even reverse engineering compiled, closed-source binaries. Third, and most importantly, it generates patches. Mythos doesn't just tell an engineer that a flaw exists, it provides the exact code needed to fix it. Finally, there is the coordinated disclosure process. When a massive bug is found, partners don't just tweet about it. They have a 90-day window to quietly develop and test the patch. To maintain transparency without risking security, Anthropic publishes a cryptographic hash of the bug report immediately, proving they found it, and only releases the technical details once the world is patched and safe. Let's walk through the sequence diagram of a vulnerability lifecycle under Glasswing. The Mythos AI initiates an autonomous deep scan of a partner's codebase. It detects a zero-day flaw and instantly submits both the report and a proposed patch to the human security team. The security team applies the fix while operating under a strict 90-day silent window. Only after the infrastructure is fully secured does the team initiate a coordinated public release. To deeply understand why this AI is a watershed moment, let's look at the actual code logic of a vulnerability it found, the 16-year-old FFmpeg bug. The developers had a 32-bit slice counter, but used a 16-bit table to track them. To initialize this table to be empty, they used the C function memset, table -1 size. In memory, -1 translates to all ones, or the hexadecimal value 0xFF. For a 16-bit integer, that equals 65535. So, the system thought 65,535 meant empty slot. Human fuzzers missed the problem for 16 years. But Mythos read the code and understood the semantic gap. It realized that if an attacker crafted a custom, malicious video frame containing exactly 65,536 slices, the valid slice number 65,535 would perfectly match the empty sentinel value. The system would get confused, bypass its security checks, and perform an out-of-bounds memory write, allowing a system crash or hijack. The AI reasoned through complex C-language idioms and memory limits entirely on its own. This graph illustrates the logic flaw. On the left, we see the normal program operation setting the table to 65535. On the right, the malicious input crafted by the AI generates exactly 65,536 slices. These two paths converge at the collision node. The system is tricked because the attacker's slice number matches the system's empty placeholder, driving the logic directly into the red node, a catastrophic out-of-bounds memory write. Finding one bug is bad, but finding a chain is lethal. Our second deep dive focuses on attack chaining. Modern operating systems use defenses like KSLR to randomize memory, meaning a single bug usually isn't enough to hack a machine. Mythos bypasses this by autonomously chaining multiple minor bugs together. It might find a small information leak to bypass the memory randomization, link that to a heap write vulnerability, and then execute a JIT heap spray to completely escape a web browser's sandbox. It does all this in seconds. This completely shifts the paradigm of enterprise security. You can no longer look at vulnerabilities in isolation. You must analyze the entire cross-domain attack path. Because a malicious AI can execute a 20-step exploit chain before a human analyst even receives the first alert, organizations must evolve. We are entering an era of machine versus machine warfare, where your security operations center must be fully automated to isolate threats in single-digit minutes. Here we see the architecture of an exploit chain. Two seemingly minor, low-severity bugs exist independently. Bug 1 leaks memory, bypassing KSLR. Bug 2 allows a minor memory write. The AI exploits Shenner access the brain, fusing these two harmless-looking flaws into a lethal sandbox escape. The final step shows the Glasswing defense. A defending AI detects this exact logical path and blocks it before it can be executed. Let's look at a critical real-time use case. Imagine you are a chief information security officer. You know AI hackers are coming, but how do you prepare? Palo Alto Networks, a launch partner of Project Glasswing, created a service specifically for this called Unit 42 Frontier AI Defense. They take the awesome power of models like Mythos and aim it directly at their clients' infrastructure in a safe, simulated way. They scan the entire code base, cloud environment, and open-source dependencies to find the exact complex attack paths a malicious AI would use. Once the AI identifies the weak points, the organization implements an autonomous security blueprint. They lock down the identity layer since AI agents act like digital users and deploy agentic endpoint security. Instead of waiting to be breached, they use the ultimate cyber weapon to red team their own network, closing the doors before the bad guys even know they exist. This state diagram walks through the Unit 42 engagement model. It begins with the assessment phase, where the AI conducts deep code scanning. When an attack path is found, the state immediately shifts to protection. This involves parallel efforts, locking down zero-trust identity and deploying agentic endpoint security. Together, these force the system into the final state, a hardened enterprise, secure against automated threats. As we conclude, we must face reality. A vulnerability tsunami is coming. As Glasswing and other AI tools scan the world's code, the number of critical CVEs will explode. Organizations must abandon 30-day patch cycles and embrace automated, machine-speed remediation. You must shift left at AI speed, meaning you integrate these frontier models directly into your development pipeline to break your code before it ever reaches production. Human speed security is officially obsolete. Project Glasswing is an incredible initiative, but it is ultimately just buying us time. We must use this time to build resilient, AI-native security platforms. To master these cutting-edge concepts and stay ahead in your tech career, I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for joining me. Our final diagram is a mind map of the future of cybersecurity. At the core, we must adapt to survive. This branches into three critical pillars: automated patching to handle the flood of 0 days, shift-left integration to catch bugs during development, and rigorous identity and zero-trust protocols to govern the new wave of autonomous AI agents traversing our networks.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks, like you are watching currently Mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available, like Microsoft, you can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our